In this video, I'm going to follow up conducting a factor analysis with factor scores and then using those factor scores to predict a criterion variable in a multiple regression with an alternative strategy of just including the variable of interest, the criterion variable, amongst the other variables in a factor analysis. So in this case, I'm still dealing with the intelligence variables, of which there are 9, and we know that it produces 3 factors, and the 3 factors are memory span, fluid intelligence, and processing speed. And this time here I want to redo the factor analysis, but I'm going to include video games in the factor analysis. Now, before I do that, I'm going to point out that you need to unselect the factor scores button when you do another factor analysis and you don't want new factors. It just will continue to get those factors as long as this variable is this option is selected, save as variables. You got to deselect it so that it stops producing factor scores. So I've already got the variables of interest in terms of the dimensions that I'm interested in, but what I'm missing is the criterion variable. In the previous analysis I showed video games as a dependent variable, or used it as a dependent variable. Now there are no independent or dependent variables in a factor analysis, but I'm still going to be able to estimate the association between video games and the 3 dimensions in this analysis. So again, I'm extracting 3 factors just like I did in a previous video, and I'm going to rotate ProMax, that's fine, and I deselected scores. Options, sort by size, I want that, and I don't want to suppress any of the small coefficients. And I click on, let's just make sure I got the maximum likelihood, 3 factors, good. So here's the analysis reconducted. Oh, I didn't, here we go. Yeah, it took a second there to get the pattern matrix. And here we have the first factor, which is processing speed. I've gone straight to the pattern matrix because that's the most interpretable and insightful matrix, as I discussed in a previous video. 0.90, 0.7, 0.42, those are the factor loadings that are processing speed, and we can see that video games, that's video game playing ability, has a factor loading of 0.39 on this processing speed factor. But video games doesn't have any other meaningful loading on any of the other factors. 0.04, negative 0.039 are trivial, small, essentially saying there's no association. And here are the other factors that are similar in nature to the previous analysis. The big difference is that I've got video games in here, and it's loading only on 1 dimension, and it's a positive loading, and it's suggesting that video games is associated with processing speed. Some points of comparison between the factor analysis approach and the multiple regression approach is that I got a beta weight of 0.35 in this case here, where it's a unique effect of processing speed on video game playing ability, and it's pretty close but smaller numerically than 0.39. So from a 0.39 perspective, it's more impressive to see a 0.39, suggesting it's a bigger effect. The semi-partial correlation was 0.26. You don't get a semi-partial correlation in a factor analysis. You get what are essentially the equivalent of beta weights. And so this is a little bit different of an approach to estimate the association between a particular variable and a series of factors. I think this kind of breaks down once you add more than 1 variable that is separate from the dimensions that are in the correlation matrix. So there are 3 factors here, and I only put 1 external variable in the analysis, and that's purposeful. I think you might run into trouble if you have 2 criteria. It'll start to distort the factor solution associated with the dimensions of interest. So that is an approach to evaluating the association between a variable and factors. I think a negative with this approach is that you can't evaluate this for statistical significance. In fact, none of the factor loadings are tested for statistical significance in SPSS. There are approaches to get significance for factor loadings, but you'd have to use a program like R to do that. You can't do it in SPSS.